CITS Pre-Calc section 4.5 is just on exponential and logarithmic equations. All they're doing this whole section is having you work on solving different types of equations involving logarithms and exponents. The only thing they give us, and something we've already talked about, is the equality of exponents. If we can get an equation so that the two bases are equal, what that allows us to do is set their exponents equal and solve for an unknown. Okay, and that's one of the techniques that we can use here. I've got 6 examples here to help work through, and we'll be doing them kind of in a little bit different way, but I'll show you how to do them and then how to check them. Now, first thing I have here is 2 to the 3x plus 2 equals 1024. They want us to use like bases. The examples or the directions in the book want us to use a like base. So what I'm going to do is I need to get 1024 into a base of 2. Well, 2 to the 3x plus 2 then, 1024 is 2 to the 10th. Now, using the equality of exponents, I can now set the exponents, 3x plus 2 equal to 10. I can solve it out, and I now know the value of x. Okay, so it's basically that straightforward. Now, the problem with the equality of exponents is it only works when we can get the exponents in the same base. Well, 121 and 5 we can't, because 121 is only 11 times 11, so there's nothing we can do there. What they want us to do now is put it in simplified form. Okay, so in a form, so if we wanted to, we could plug it quickly into a calculator. So what I'm going to do with this is I need to get x alone. I'm going to take the log of both sides. Now, I could take any log, but just because it's easier to write, and that's, to be honest, that's the only reason I do it, I take the natural log, and now I can solve it out using my rules for exponents, or for logarithms. I can move this negative x in front, I can divide by the natural log of 5. Now remember, that is not the natural log of 121 over 5. It's 2 different logs. Now I divide by negative 1. And I have it in a calculator ready form. So if I wanted to find that value of x real quickly, I could take the log of 121, divide that by the log of 5, and then divide it by negative 1. And I've got the value of x to decimal places. This is the exact answer. Okay, there is something I'd need to round or use at some point. The rest of these are going to ask us just to find exact answers, or be able to get them in that form. So number 22, again, the bases I cannot get into the same form. So this is a little bit tougher. I'm going to take the log of both sides. I'm going to pull the exponents in front. Make sure you put brackets around them so you remember to multiply that log of 3 through and that log of 4 through. Now, the rule for solving an equation, these are basically linear equations, there's no exponents in them anymore, is get all the value of x's to one side and get x alone. So I need to multiply this log of 3 through. Now, I need to get everything with the x's on the same side. So I'm going to get x log of 3 minus 2x log of 4 equals the log of 4 plus 2 log of 3. So I move anything without an x to the right, brought everything with an x to the left. I can then factor an x out. And divide by, technically, the coefficient. So there's the top over the bottom, log of 3 minus 2 log of 4. And there is my value of x. And you can plug that in the calculator and see a decimal approximation if you wish. Number 28, we have logarithms on both sides. Well, we had a rule in a previous section that said if we have the log of the same base on both sides, we can just take what they're logs of and set them equal to each other. So I can solve this out. It's quadratic, so I get everything to one side. I factor it, and I find the values of x that work. Now, always important, plug them in and check them. So I plug 7 in, I get 49 minus 42, which is a log of 7. That one works. I plug negative 1 in, I get 1 minus 6 times negative 1, so 1 plus 6, which is a log of 7. That also works. But make sure you plug them in and check them, because they might give you something that doesn't work. Okay, number 36 is a little bit tricky in the beginning. I have the log of x cubed equaling the log of x all squared. Well, this one follows my rule for logarithms. So this one, I can pull that 3 in front. I have to use a common log here because that's what they want us to use. On the right, I can't. That is not the log of x squared. It's the log squared of x. So technically, it looks like that. But it looks really ugly like that. But I'm going to leave it there just so you can see how it works. Now, it's quadratic. I've got a quadratic log here and a log there. I need to get everything on one side. Oops, that should go minus there. Now, there's 2 logs here, 2 log of x's. I can factor out a log of x. I have left over a log of x minus 3. I can then set each of those logs equal to 0 and solve them out. Well, this is base 10, so I move it over and I get x equals 10 to the third, so x equals 1,000. This is base 10, so I move it over and I get x equals 10 to the 0, so x equals 1. And those are my 2 values that solve that equation. Now, technically we should leave it written this way, but I wrote it that way so it looks like something you've done before. I don't really know, I guess I've never seen it this way written. I don't know if it's completely wrong or I just haven't seen it that way. But just so you can see how it's done, that's why I wrote it that way. 56 finally lets us get into the calculator. Okay? Now we've got a couple of ways we can do this. We can graph this by moving everything to one side. And find the zeros of the function. Okay, in other words, I'm going to find the x-intercepts where I'm crossing that x-axis. I don't like to do that. I like to leave them on opposite sides so that when I graph them, okay, and I'm going to turn this on here. Notice how I put the left side of the equation into the top equation, the right side into the bottom, the y2 equation. So then when I graph it, I've got a graph and I've got a line. The reason I like that is because when I use my calculate key, my second trace where I get my calculate, all I have to do is go down and find the intersection point. Hit enter. It wants first curve. If you look at first curve here, the first curve is y1. That's where I want. The second curve is the y2. I want that, so I hit enter. Does it want me to guess the solution? Yes, I do. It'll do the calculation. I know my intersection point happens when x equals negative 1.052. Well, I should round that and make that a 3. And that is the solution. Now, technically, all of these could be done that way, but that's not what we're teaching here. Okay, so if I wanted to solve this one out real quickly, I could do the log of x squared minus 6x and then the log of 7. I could graph those. And I just have to find those intersection points. So second, calculate intersection. And I need to be close to the curve. So y1, I'm there. Oops, I gotta get on that curve. Let's find my graph here. Here I am. That one, y2, guess. -1. There's one of the points. Sorry if you can't see that. And I could do the same thing with the other ones. Second, calculate, intersect. I need to trace it over so that I'm on the other side. Right now it's tracing down below the x-axis, so I should be there. There it is. You see my dot, my cursor blinking there. So first curve, enter, second curve, and 7. So we could technically find them all with that, but I do need to see the algebra, because that's what we're actually teaching here. Okay, so I'll let you guys get to work. You can check your answers with your calculator if you like, but you need to show me how you did them.